Good morning, everyone. Thank you a lot for joining us today. And it's the last day of an amazing event, VMware Explore for 2023. It was amazing. I think lots of interaction we've seen with customers, so many new technologies that we are now gonna help you along with the products we have and solution to adopt in the near future. So the purpose of this meeting is to cover or to walk you through the lab VMware Tanzu application platform. So we're going to help you to walk you through this lab, do some of the testing for some of the modules in this session, but later on the lab is going to be available in the public catalog for VMware hands-on labs, so you can take it at your own pace, whenever you like. So just like the two, me and Benoit worked on creating this content for this lab, so let's just go through a quick round of introductions. So my name is Mohammed Salim. I'm a lead solution engineer, pre-sales, based out in Dubai, dealing with public sector customers. I've been at VMware for almost 8 years, working with different technologies. We started first with the vRealize, the ARIA suite, Tanzu. So I'm working along with my colleague, Benoit. If you want to introduce yourself.
I'm Benoit Ferratris. I'm based out of Singapore. I've been at VMware for the past 12 years, covering many products, and right now I'm a solution architect working for Tanzu Customer Zero team.
Great. So I just want to tell you here a story about how we construct any HOL lab. So usually we have some meetings with the business unit lead, to understand more about what they would like to include as part of the lab, like maybe a feature walkthrough, maybe some kind of demo that the customer would benefit a lot from testing in the lab. So we do this usually, we have this meeting and then we go through a storyboard of everything we discussed, and then we come up with this story of how the flow in the lab will go. So you will see that there are some modules that are going to be more focused towards developers, another module that is going to be focused more towards operator. But at the end, we are trying to get all the requirements from the tab PMs and apply this to the lab. So you will see in this lab specifically, we worked over 4 months to get everything you're going to see in the lab there. So there were lots of iteration that we had to go through just to make sure that everything that we discussed with the PMs is going to be included in the lab. Before we discuss tab here, I would like to understand from you first, like, who's you into like new to Kubernetes perhaps, who's developer side, who's operator side? So let's start, who's new to Kubernetes? Great, who's more operator? Great, and who's more developer? Awesome. Have you already started hearing like testing Tanzu? Did you play with Kubernetes, Tanzu Kubernetes Grid, apply this maybe on top of your vCenter, on a public cloud offering? Okay, good to know. So let's discuss here what tab is all about, right? So it's good definitely to have mix of different roles here when we go to talk to customer about tab. Usually we're gonna touch upon what the operators is doing, what the developer is doing, and what the SREs and DevSecOps team are doing all of these roles. So it's good to have this. But let me ask you, like in a typical scenario, if you want today to launch any application in production on top of Kubernetes, it's not an easy, like Kubernetes is gonna be easy, like if you're gonna look into this just to run a deployment or kubectl apply deployment or bod, it's gonna be easy. But when you come this in production, it's not that straightforward because there are so many other aspects that you have to consider when launching an application in production. So you will find out eventually that you're having lots of YAML manifests that represent different configuration that you need for the application. For instance, how are you going to do the routing, how are you going to do the services, how are you going to make sure that you're able to access maybe the API of your application and all of this. So the toil to manage all these YAML manifests is causing what we are calling a developer experience gap. So if you are a developer today, you just need to focus on the business or the core business logic or the core logic of core business of what your organization is doing. And this is causing this kind of developer experience gap. So if you look into this from the personas that you usually deal with to launch an application. Usually you have the developer want to develop and write the code, and then they want to go back to operator. The operator want to avail the infrastructure that will be used to host this application. There is security team also that you need to work with to make sure that your application is secure, to make sure that all the tests has passed and all of this. So this kind of let's say individually configured kind of silos when it comes to launching the app is what is a big problem we have with Kubernetes when we go and talk to any customer. This is something that everyone is using Kubernetes, but how they are using it, it's not streamlined across the organizations. And you will see that there are some applications maybe or some business units inside an organization, they are using it differently than the others. So there is no this kind of unified approach to launch application into production. And this is what exactly Tanzu application platform is all about. So if we're going to talk into the three main pillars that Tanzu application platform is helping customer with, it's going to help to unblock developer productivity, build rapid and sustainable paths to production, and coordinate the work between developers and operations team. So if we're going to dig deep into each one of these, we're going to talk about first how we are unblocking developer productivity. So the first thing is that for you as a developer, you want to have patterns or templates that you can use across the organization to have a skeleton, let's say, of your source code of your application. So if you have ever used Java, if you are Java developers, there is something called Spring Initializer. This is well known amongst all the Java developers. Spring Initializer was more of an engine that will help you to kickstart a Java application and be able to get all this kind of source code like the BOM, XML, whether it's going to be Maven, Gradle. You can define which Java version you would like to include. You can also inject some dependencies from Spring. We are doing exactly the same thing here with what we are calling Application Accelerator, which is a very important component of TAP. Application Accelerator is all about having this pre-configured template that your developer, that your teams, that your project owners can use to have a skeleton or a base template to launch an application. So you will see this, and Benoit will walk you through how you can work on this through TAP, and how you can even, the created projects can be pushed immediately or committed immediately to a Git repo if you want to do that. So this is going to be something that helps developers to kickstart projects real quick, and this is not tied to any specific language. You can come with your own framework, whether it's Python, Node.js, Ruby, whatsoever. You can create your own accelerator for this and share it with your own developers. The second thing is that we believe that you as a developer should spend most of your time focusing on what you're doing on your IDE. You're doing a great job by working on IDE, developing applications, making a profit to the organization you're working for. So we are trying to bring you everything when it comes to TAP directly to your IDE. So you will see here that we have some integration we've added to IDEs, to be specific, VS Code and IntelliJ. What we are doing is that you will be able to iterate the code, debug the code, directly from the IDE. So you will be able, when you go into the VS Code, as you can see here from screen, you will be able to run the iteration of your code, be able to make sure it runs according maybe to the security guidelines that your organization is mandating. You will be able to see if there are any code issues in the code you are running. You will be able to see if there are any CVEs being identified. You will be able to debug it. All of this is going to come close as much as possible to you in the IDE directly. So this is also a super cool feature that, that so many TAP customers are happy with it, because this IDE tooling is something that gives us a great value when it comes to helping developers to accelerate their productivity. And the other thing is that we're giving you also a TAP GUI. Now it's called TAP Developer Portal. So we're giving you a nice GUI to check all the resources that are related to your application, so you're able to see maybe the application resources in terms of the pods, the Knative service being deployed. You can go down deep to also have kind of called another feature called App Live View, where you're going to be able to see or troubleshoot more metrics of performance around your application, be able also to debug this directly from your code. So this is going to be something good to see for as a developer, and also part of it, operator will be able to see these workloads and be able to troubleshoot these kind of workloads if there are any problems, or debug any problems that may appear there. If you have any question, feel free to stop me anytime, raise your hand, and we'll be happy to take it. The second pillar is how you can have predefined paths to production. So we're going to go through these, how Tab can help you with this. So whenever we go to any customer today, and we're going to discuss what you are using for CI/CD pipeline, like CI/CD tooling. So many customers would say we have using GitHub Actions, GitLab, Bitbucket, whatsoever, right? Azure DevOps, so many tools. The challenge we have with such tools is that they are not kind of consistent when it comes to, first of all, teams that they are using. So you might see team one and the customers, they are using Azure DevOps, a specific pipeline maybe for their application. Maybe there is another pipeline used by another team, maybe even for the same language, but just another pipeline that is used because this team has developed it. What we are trying to do with Tab is that we're going to give you an automated, this kind of path to production, going to be automated, what we are calling concept of supply chain. So the supply chain is going to be more of a streamline of everything you are doing in a CI/CD pipeline, but it's going to be unified across all these kind of languages or framework you are using. So you don't really need to care about what configuration you may need to have for Java, or what configuration you may need to have for Python. Everything is going to be configured for you out of the box with supply chain. In this part specifically, we're going to talk about how we can help you to build container images. So in a typical scenario, if you're going to go and talk to any customer, how you containerize your source code, your application today, most of them would say we're using Docker files. Everyone was happy with Docker file, right? This is how we learned it, even the journey to Kubernetes. Docker files could be good for maybe few applications, maybe 1, 2, 3, 5, 10 even applications. But think of it that you're going to go to your office next day in the morning, and there is a big vulnerability identified in the base image, perhaps, of your Docker files or your applications, these kind of container images. You have to go to every Docker manifest or Docker file manifest and go and update from Ubuntu latest or whatsoever, update the base image to make sure it's all streamlined. And then you have to build all of them again. TPS is going to take all this hassle off your shoulders. So what TPS does, it's called Tanzu Build Service, which is an important component of Tab. TPS is using a framework or using kind of an open source project called CNB, Cloud Native Buildbacks. Cloud Native Buildbacks is a very smart tool that will be able to detect the source code of your application, and it will build you a container image. So usually you don't need to have even any tooling installed in your local machine. What you're going to do is just for TPS, it's going to be more of, it will detect the source code of your application, whether it's Java, Python, Node.js, Ruby, R, whatsoever, and it will containerize this source code or this application for you. Moreover, it will push this container image to any registry you have of your choice, whether this AWS, Harbor, any kind of registry you might have. TPS will take an important role in pushing this also to a registry of your choice. So bear in mind here that you as a developer, you don't need to install any local tools to containerize the application. Everything is going to be done on behalf of you using the TPS. Another important concept, this is what I was discussing when it comes to supply chain. So what you see here is supply chain itself. So everything you go, so we first start with, I'm going to go through this in details when I go in the lab. But we start with this component called Flux CD. So Flux CD is going to be, call it the watcher for any Git changes. So if you're going to commit maybe a new change to your code, you're going to commit this to a Git repo. This commit will trigger Flux CD, will just get this change and will try to reconcile or apply whatever changes you made. We have here some, also if you want to do testing for the source code, we have something here called Tetcom pipelines that you can go to test the source code. And then this is a cloud native buildback that is used to build the code. And then we have the Kubernetes configuration, kind of how you run this in Knative. But the moral story of this is that we are flexible. So we're calling Tab is more of a flexible or modular approach when it comes to the deployment. Means that if you today as a customer will come to us and say, I prefer not to use Tetcon and I prefer to use Jenkins instead. So we're going to be able to swap out some modules for another. So we're going to help you with this. So we're going to help you integrate with existing Jenkins. I'm sure we're going to have more integrations coming, like GitLab integrations, and all of this is going to be there on the roadmap. So if you want to replace one component for the other, we're going to do this. At the end of supply chain, think of it as more of templates that are being calling out different component or different custom resources to do a specific job. These custom resources, whether it's going to be coming from Tetcon, whether it's going to be coming from Jenkins, or another application, it's going to be the same idea. So just calling out these kind of different tooling throughout the supply chain. And more important about the security here, so how security folks are going to work with us. So as part of Tab, we have what we are calling source scanning, testing, and image scanning. So many different phases you will see here if you're going to go deep into the supply chain. So you will see first that we have ability to provide you with source scans. So you will be able to define if there are any scanning in the application you have. We will do the source scan, and we will brought you any maybe CVEs being identified. You can define based on a scan policy whether you want to block even the continuation or the deployment of the application, or you just want to whitelist maybe the CVE and allow the supply chain to kick in. We have also scanned for images, so TPS. Once it does this kind of pushing the image to an image repository, we will also be able to scan this image and define any kind of CVEs being identified on this. There is also another important feature that says we can also sign, so if you want to sign the images, we have a component called cosign that can help you to sign the image if you want to make sure the integrity of the images is meeting what your organization is looking for. And for operators people, we're going to also scan or store all this information about the scan results, whether they are from images, from the source scan. All of this will be stored in a metadata store so that you can query later on maybe this CVE's information, the scan results. Maybe if you want to feed this into any automation tool or something for alerting or any kind of third-party integration for any action you would like to take based on this CVE results. This is all going to be also packed into the security, and this security backed in the supply chain. So if you're going to talk into supply chain on full scale, you will see everything I discussed now is going to be part of supply chain. So watch for the get, scan source, run a test, build the image, sign the image, store all the scan results, Kubernetes configuration to run it completely on your Kubernetes using Knative services. All of this will be taken over by the supply chain, and this could be applied to any framework or any application you have without the need to modify any of the configuration, because this is the concept of supply chain. And this is how we really Tab is going to help you with. So you will see this kind of everything we discussed here around the app accelerator, around the code sign, testing, and everything. This is how the journey of the Tab goes. So from all the way from zero to hero, from just an application with just a source code all the way to production. You will see that during these stages, the supply chain will take you through every and each stage, and you will be able to see this kind of collaboration happening between dev, sec, ops teams. So you will see in the green, we have the concept of what we are calling the inner loop. We're going to be more focused into the developer. So the concept like app accelerator, where he can develop a request, like I mentioned, templates to run or skeleton templates for the applications, to be able also to have an API portal if they want to expose some of the APIs for their application. If they want to have this IDE tooling, this is all of what we're calling inner loop, and be able also to debug this application. And then we go into the sec team where they're going to test and build the application, like this kind of testing for the source code, image scanning, source code scanning, and then all of this information will be stored in the metadata store, and then the operations team will look into the Kubernetes manifest being deployed, the Kubernetes service, and so on and so forth. So this is what Tab is all about. So linking or bridging the gap between these three silos, Dev, Sec, Ops teams, in just a matter of what we're calling supply chain. So everything here with the help of Tab, with the help of supply chain, everything here will be done seamlessly in your organization. So the key message of what we are doing with Tab is to make your developers happy through this app accelerator, the IDE tooling, the concept of shift left when it comes to security. We're also happy to bring your own tools. If you would like to bring your own tools and integrate with supply chain, we can do this. And definitely embrace the concept of DevOps culture or DevSecOps culture for a smooth path to production for your applications. And I'll let my colleague Benoit speak about the lab experience.
Okay, so we are going to get started in a minute with the lab and more hands-on work, but just before I wanted to tell you a bit more of the environment itself and also Tab itself, how it has been installed and what it is. So the first thing to understand with Tanzu application platform is that it's an application itself that runs on a Kubernetes cluster. Okay, so to be able to start with Tanzu application platform, you need one or multiple Kubernetes clusters. Here, in the case of the lab, you have a full real-life environment, which is a vCenter with few ESX. We have Tanzu Kubernetes Grid installed on top of it, which provide Kubernetes clusters. We have a Harbor registry where we're going to store all our container when an application is being built. We have NSX Advanced Load Balancer to provide, to allow Kubernetes to create services and load balance across multiple pods. And above this, I will say, infrastructure layer, we install Tanzu application platform, okay? So in the lab, as you might see, it's mostly VMware focused with VMware product, but Tanzu application platform can be installed on any Kubernetes cluster, so you could install that on EKS, AKS, or your own homegrown version of Kubernetes. So Tanzu application platform itself, you've seen that before. It's a lot of features and it's a lot of feature and a lot of things you can integrate. So it ends up being a lot of components that are being deployed on this Kubernetes cluster. So the way it's deployed is we deploy that through a tool called KApp, which is part of the Kernel suite. So KApp allows you to package microservices application and deploy them and update them very easily on a Kubernetes cluster. So that makes the experience very easy for you to install Tanzu application on top of a Kubernetes cluster. You just have to fill a manifest that with few parameters, and then KApp takes care of the rest and install all the components. To make things even simpler for you, we have a concept of a profile with Tanzu application platform. So depending on how you want to use Tanzu application platform, we will only install few components and not necessarily all the components. So that's something you have to figure out when you start with Tanzu application platform. If you are really new to Kubernetes and this concept of cloud native, we have a team called Tanzu Labs. It's professional services that can help you out to get started. So I will strongly encourage you to think about it if you want to ramp up quickly on Tanzu application platform. Any questions so far? Okay, so before we get started, I wanted to come back and talk about a few terms that we use a lot with Tanzu application platform. The first one being this concept of supply chain. So we call supply chain, and we talk also about Choreographer. So Choreographer is the open source tool that provide these supply chain concepts, okay? And the supply chain concept, I think Mohamed explained that well before, it's an abstraction of your whole process from code to the application, where you have a component that could be swapped at any point in time. So depending if the supply chain will analyze what type of application it is, and it will use the right component to push your application to production. The second important thing to know about is this concept of app accelerator. So that's basically a template that a developer will be able to use. Through Tanzu application platform, this template is automatically customized, so you can straight away use the template and almost push it to production straight away, because as part of what we will see in a minute, the template is customized and all the configuration is put in place so it will deploy properly on Tanzu application platform. Next, something that we didn't talk before, many applications, they require external services such as database, message queue, and so on, you name it. So Tanzu application platform will allow you to integrate with these external services through something we call Service Toolkit. So Service Toolkit will help you declare these services that are available outside of the Kubernetes cluster or outside of the platform. And the developer will be able to claim these services as part of the deployment. So Mohamed will talk a bit more about it later in the lab. But if you are more interested about that, we have a full module, I think it's module 5, that you could take later on either in the self-paced lab area or later when the lab will be available on internet. Finally, 2 more things. We will show you the TAP GUI or the Tanzu developer portal, which is this main UI where people could go. So it's, I will say, optional. You don't necessarily have to go to the UI. It's just a nice way to visualize the supply chain, access documentation, API, and see the workloads that are running. Along with this platform, with this UI, we also have a CLI that I'll show you. And finally, I'll go quickly on that. I think Mohamed explained a lot about it. Tanzu build service is key in this supply chain because that's really what creates all the containers that are going to run in your Kubernetes cluster. Okay, so without further ado, I think we are going to start the lab. So we are going to go through a sequence. So first, we are going to start with module 3, which is talking about rapid onboarding for developers. So we are going to go through the developer experience first, and we'll go from 0 to deploy an application. So I've seen that many of you are not developers, so it should be simple enough. It's just few clicks, but I'll try to explain what we are doing step by step. And then, while the application is deploying, we'll show you what's really happening in the back end, in this supply chain, all the steps. Mohamed will walk you through all the steps that are being done to deploy this application in production. So we are going to start the lab, so you should be logged in already. You can enroll you can enroll for the lab 2435-01, so it's written on the board over there. And then you should end up with a screen that looks like that. So, as I was mentioning before, we are going to start with the developer experience, which is module 3 and developer. So you should start on page 92. Okay, so before we start with developing an application, I wanted to talk a bit more about how we provide things to a developer. So for the developer to be able to create its application and then deploy it to production, there is some work that needs to be done by the operator to provide the environment. Yes. Is it a question or an issue? Yeah. Okay, so to get the developer up and running, the operator will have to provision a project or a code repository somewhere, so the developer can store the code in a central place. The developer also needs a registry space where all the containers that are being built along the process will need to be stored. And finally, the developer will need a Kubernetes namespace where its application will be deployed. Okay, so that's really the three things that are required for a developer to get started and use Tanzu Application Platform. Tanzu Application Platform help you provision that seamlessly, especially the namespace. If you want to have a customized namespace, Tanzu Application Platform will help you customize this namespace automatically. So at the first step, we are going to log into all these different tools to just show you that it's there, and then we'll go through the developer experience. So this lab, it's only one machine, so we had to provide these two profiles, one for the operator, one for the developer. So that's why the first step that we are doing is just logging in as the developer. So for that, we open a terminal and we just log in as the developer user. Then we are going to launch all the application from the terminal itself because that's the developer profile that we want to use for this part of the lab. So we are going to launch Firefox, so we can log into the different tooling that are going to be used in this lab. So first tool that we are going to check is the Harbor registry. So let's log in and confirm that we have a private project that has been created for our team, so app team 1. And I am the project admin of this project, so I'll be able to push container to this registry. The second tool that we're going to log to is GitLab, which is where the source code will be committed. So I'm signing in, and I can see that I have a project already created called app team 01, which is where I will be able to create a new repo for all the application that I'm going to create. So now the other thing to know for this lab in particular about GitLab is going to be our authentication source for Tanzu Application Platform and Kubernetes. So another thing with Kubernetes and Tanzu Application Platform is that to provide a better experience to developer, we are using a single source of authentication, which is GitLab. So we're going to see that in a minute. There will be SSO when we log into TAP and also when we log into Kubernetes. So that's the next step. We are going to log into Kubernetes and check that we can actually see what's currently running in our namespace. So I'm just going to do a kubectl get pod, and automatically it's going to redirect me to GitLab, and because I'm already logged in GitLab, it's going to authenticate me and get back to Kubernetes. So if you close that window and go back to the terminal, you can see that now I can see the pod that's available in my namespace. Okay. So this integration is done by Pinniped. Pinniped is part of TKG. When you install TKG on top of vSphere, you can enable Pinniped, and Pinniped can be integrated with any OIDC source and also Active Directory. Okay, so we close that. Okay, so now that we've seen that we have a source repository, we have a registry where we can push container, and we are connected to our Kubernetes cluster, we can get started with the Tanzu Application Platform, and we can start creating an application. So for that, for the purpose of this lab, we are going to use VS Code for that. So make sure you start VS Code from the terminal itself and not from the bottom icon. So you are logged in as the dev lead, the developer, and not as the operator. So as we were saying before, a way to get started very quickly with Tanzu Application Platform when you develop a new project is to use Application Accelerator. So Tanzu Application Platform comes with a few app accelerator that are part of the product out of the box. Application Accelerator, it's also a framework, so you can build your own if you want. You can also modify the one that we provide out of the box. It's really something flexible. All this configuration is stored on a Git repository, so it's very easy to get that change. You just need to do a new commit to your Git repo, and all this change will be pulled into Tanzu Application Platform, and the next time an app accelerator is being used, the change will be there. So for the purpose of this lab, we are going to use the accelerator called Tanzu Java Web App, which is pretty much a web application that is doing a hello world. So to get started, the accelerator is going to need just few information to know what to do when we are going to deploy this application. So the first things being a name, so we are going to name it My Java Project. And then the second thing that we need is we need to provide the registry where the developer has rights to push a container. So we've seen before that the registry was this Harbor registry, local one, and the project name was appteam01. So if you don't want to write everything, you can drag and drop from the manual. Okay, so our accelerator knows where to push the container. Now we need to also tell the accelerator where the source code will be stored. So this lab has already GitLab pre-configured here, so that's why you don't have to enter the token. If it's the first time you use accelerator, you might have to enter the token, and then it's going to be saved into your profile. So when you use a source repository, usually you need to provide, the project name where it's going to be created. So we call that the owner. So in that case, it's going to be appteam01. And then inside this project, we're going to create a repo for this application in particular. And we are going to name it the same as our App Accelerator project name. So just a quick one. The first step, the name that you see here is the name of the application inside Tanzu Application Platform. The second step, where we set up the repository, the name that you put here is the name that you will see in GitLab. So usually we try to keep the same name just so it's easier, but it's not necessarily mandatory. So it's going to validate, unable to fetch, okay. Ooh. Looks like the lab. So we had issue with the lab in the past where it's getting slow. So let's debug live, workload, list. Let's see, no, it seems to be fine, okay. So let's try again. Okay, so looks like my Tanzu application platform is not going well at the moment. So let's see. Okay, so it's there. 400. Do you guys have the same error, or are you able to go through? Doesn't seem to. Okay, it's okay. So it's going through. Okay. Okay, so let me try one more time. Otherwise, I'm going to quickly spin up a new lab. Let's see. Oh, 400. Okay. So I'm going to, sorry for that, I'm going to spin up a new lab very quickly. So bear with me, I'll be back in a second. Okay, so going to do it again very quickly. So start the terminal here. Okay, so I'm logged in. Now I can start code. So yeah, these labs are what we call nested labs. So the ESX lives inside a VM. And sometime when you run a Kubernetes cluster in this type of environment, you might experience slowness because it's really virtualization inside virtualization inside virtualization. That's a lot of layers. And you might end up with this kind of slowness. So that's something which is great for labs, but definitely not good for production. Okay, so let's see. So app team 1 and my Java project. Okay, so okay, here we are. So we are back online. So everything is ready, and we can generate the project. So it's going to first ask you where to store all the file locally, because when you develop, you have your file locally, and they are also pushed to a repository. So in our case, GitLab. So I'm going to select Git root. So in some case, this window appears in the background. So if you feel that your screen is frozen, it's because it's in the background. So you have to click at the bottom icon and just switch to this window. And then the app accelerator will take a few seconds to generate all this code skeleton. And then we'll be able to open this new project and start developing and testing. So usually it takes a few seconds to go through. At the bottom right, you have a little window that tells you, hey, now that we have this new project created, do you want to open a new Visual Studio Code window? So it's going to, so you will see just your application. So that's what you want to do. If you miss this pop-up, you just need to open the folder where we just created the application. So that's okay. So to make things more clear, we are going to close the code window that was at the back and just stick with only one Visual Studio Code window, which is the one with the Java project that we just created from the accelerator. So what you can notice on the right is that your project already has a bunch of files. So it's a Java application, so you might notice the pom.xml. You have a Maven wrapper for building and testing, and few other things. So the important part in a Java application is usually under the src source folder. So we are going to go into this folder to check the code that has been generated, and we are going to try to run it just to see if it's working well. So as I was saying before, this application is really just a very simple web application using Spring Boot. And we are going to be able to debug it straight away because we have the Java plugin already installed in Visual Studio Code. So when I'm going to click on this little debug button that has automatically appear inside my application.java code, and it's going to build the Java application and run it straight away locally on my machine. Okay, so this is like the standard thing that developers are used to, which is like running the application on the machine. So you should see very quickly completed initialization, which means that the application is now up and running. So to be able to test it, we are going to open a new terminal. And we are going to use this little tool called HTTP to request the local server that is being used for development on port 8080. So we just do that, and we can see that the local server reply with this nice message, which is in the code. So I'll show you that in a minute. So do you all get that page 107? Okay. So let's move on. So now let's stop the debugging and let's go back to our file. So let's just look quickly at the controller, so you can close the terminal if you want to see more of the file. So the message that we've just seen is actually coming from this hello controller, and you can see that here. So the app accelerator has created all this skeleton code that you can start from, but it also comes with this config folder, and you have this workload.yaml. So that's pretty much one of the only YAML that the developer has to know. And this YAML file describes the application itself and will help the supply chain make the right choice when it comes to testing the application, scanning the application, and deploying the application in production. So because Tanzu application platform is really based on Kubernetes concept, everything that is done in Tanzu application platform relates to a Kubernetes custom resource, okay? So what you see here in the YAML file, it's going to be a custom resource in Kubernetes. So that's why we are using, I will say, extensively labels and annotation, which are two concepts from Kubernetes. So this label and annotation will allow the supply chain along the way to use Kubernetes selectors to decide what to do. So the labels that we can see here, we have the first one, it's workload type, so it tells the supply chain that it's a web application. And the supply chain has been configured to support different type of applications. So if the labels is found web, if the supply chain found web, then it's going to go through a certain path. It also tells that it has test, which means that we will need to kick in the test phase in the supply chain. It tells that as part of the build process, we want to configure actuators that will give you metrics when the application will be deployed. And finally, we have these labels part of that basically will be used in Tanzu application platform GUI to group all components of a single application together. Then we have the spec part that will tell Tanzu application platform where the code comes from. So here we have this the URL of the GitLab repo. So we can, by the way, check that. If you go to GitLab, you can see that it has been pushed already. All these files that we are seeing in VS Code, they are already in GitLab as well. So we have the source, and then we have few parameters that are being used for specific steps. So for example, for the build process, so for Tanzu build service, we need to give Tanzu build service the JVM version that we want to build the container for. So that's one of the information that is provided here. But if you know well build service and cloud native pack, you might want to add more parameters here as well. So that's just an easy way to set up your whole application here, and that's the only place where you need to do that. There is also a few more annotation that will tell the supply chain which language to use. It's going to be leveraged especially for the testing, so to use the right pipeline for the testing, and a few other things. So that's really it. That's really what Tanzu application platform expect when you want to deploy a new application. Okay, so to get the supply chain kicked in, we have a UI integration in the IDE, and you just need to do the action that we call apply workload. So that's what we're going to do in a minute. So what it does when you do that, it basically just run this Tanzu CLI command here. So you can see the command here. So you can do that from the GUI, but if you want to automate this kind of thing, it's fine. You can just use the CLI. It's the same thing. So it's been, now we have this custom resource created in Kubernetes, and it will go through all the steps inside the supply chain. So if you keep watching that, because of the slowness of the lab, at some point it might break. That's fine, the supply chain is continuing in the backend. It's really just the flow of logs that is being stopped. So no issue if in your case it just stopped, okay? So this workload, you can see it in the CLI. So let me just show you that. So that's not part of the manual. I'm just showing you a few things while the log are logging. So if you list all the workload, you will see that we have this new My Java application that is being built. And if you do a get, you are going to see all the steps that the supply chain will go through. Okay, so all these steps, that's what Mohamed is going to show you in a minute. But I just wanted to highlight the fact that that's how it is in Tanzu Application Platform. As soon as the workload is being pushed on the Kubernetes cluster, you can watch the current step either in the CLI or you can also look at it in the GUI. Okay, so in the GUI, if I look at my current workload, I'll be able to see all the step that the supply chain is going to go through. Okay, so same thing, CLI, UI, it's up to you, you choose. You will see the same thing. So before I hand it over to Mohamed, I just wanted to highlight something that is very important with Tanzu Application Platform. All these steps that you see here and the workload itself that we are seeing here are what we call Kubernetes custom resource, okay? So that's why I'm saying Tanzu Application Platform is really it's leveraging all the concept of Kubernetes, so you need to understand and know Kubernetes well when you are going to operate the Tanzu Application Platform, okay? So all the steps are going to be resources that are stored in Kubernetes. And as you may know, when you have a new resource being created, you will have a Kubernetes operator that will watch this kind of resource and act on it. And that's how the whole supply chain is working, is that you create this workload resource, and then there will be a Kubernetes operator that will pick it up and start the supply chain. And then when its role is done, it's going to create another Kubernetes custom resource, which will be picked up by another operator, and so on and so on. So we are leveraging this concept of custom resource in Kubernetes, and the operator are going to do this constant reconciliation of all the steps. So if at some point something breaks, it might be reconciliated at the next reconciliation loop. So it will constantly watch all the resource, and it will constantly move the supply chain on. Okay, so I'm going to hand it over to Mohamed, it will go through all these supply chain steps. But just before that, any question on what we've seen before, which is really what the developer will do with Tanzu Application Platform? All good? Okay, so Mohamed.
Thank you, Benoit. So just continuing on this application here, if we're gonna do one more refresh to the command we run to apply the workload, you will be able to see that we are progressing down the supply chain. So now we are in the image provider. Having this unknown status is because it's already being in the motion, so the steps is being executed already. So you don't really need to bother yourself about this, just give it some time. and it will be healthy. I'm sorry for that. You'll see here that this is the status of the build bod. So we're saying the build bod, this is where TPS is being kicked in to start building the container image. So you'll see that there are some in it here, 5 out of 7, and then it will be ready. Once it is ready, then you will see that we are progressing in the build. So as of now, we are in the image provider status where we are building the image. So if you're gonna give it some time, you can just use this command instead to tail. I'm not good with Ubuntu, sorry for that. Yeah, like. So yeah, now the image provider is true, completed, and now we're gonna scan this. But anyway, let's just skip this kind of CLI and go through. Just wanna show you here. Let's just end all of these tabs. Let's close all of them. So let's close terminal and let's close also VS Code. The reason is I want to launch these tools again one more time using the HOL user, right? So if I'm gonna go here to VS Code, if I'm gonna go here to terminal, you'll see that the user here is HOL user, while with Benoit it was dev lead. So let me scroll to, we're gonna open the manual and we're gonna go to module 2 here. So jump straight ahead to workloads and supply chain. So as we discussed and as Benoit discussed, a workload is nothing other than just a YAML manifest or kind of representation of how you want your application to be deployed in production. So the workload usually, once you define this, once you define any additional parameters you would like to add, the next step is to add or to make this applied, and it will go through the supply chain. So let's do this command. You should see that you've already done this, I guess, so. Okay, so Tanzu apps workload. You should see now that the application that Benoit has run is ready. And if you're gonna go through this, you will see now that all stages are marked as true. Remember from the dev lead, we had some status that were unknown. Now everything is true. Let's now discover the workload CRD, right? This is what, again, Benoit has showed you, but let's just go through this. So from the VS Code, let me just do this here. Yeah, from VS Code, I'll just click here on Kubernetes. You will see clusters are loaded. I'll just go to tab HOL. I'll go to custom resource here. I'm gonna scroll down all the way to workload.
Just very quickly, here we are using VS Code just as a way to easily look at Kubernetes CRD. Okay, it's you can use whatever tool you want. You can use kubectl. That's the same thing. Here it's just for the purpose of the lab because we know that the experience is not that great where you have to type a lot of command line. We prefer to use a UI to go through the CRD. Okay, so that's why we use VS Code. It's there. It has a nice plugin to look at Kubernetes resource, so we use VS Code. But it's not. It's not. You can do whatever you want to watch this kind of resource in Kubernetes.
That's right. Thank you, Benoit, for that. So what is really important here, like Benoit mentioned, is that since this is Kubernetes, we are relying on Kubernetes' way of operating labels and like to be able to select maybe properties or having this kind of label and annotations. So you will see here whatever label we are setting here, this is gonna call out to a specific maybe supply chain or a specific parameters to be added as part of supply chain. So you will see, for instance, here workload type means web. There will be one of the supply chain, I'm gonna show you this when we go through the supply chain, that has the web as part of selection. So whenever you have a Kubernetes or workload with selection set or label set to web, that means that this supply chain will be called out. So all of these are kind of configuration that gonna give you an easy way of configure this. So when you go to supply chain, I'm gonna show you this. You're gonna have web server as part of selection, but if you have web, that means that the specific supply chain we have configured will be called out. You can define here other properties like Benoit mentioned, what is a Java version to be used. You will see here also some properties related to Knative, for instance. This is all gonna impact when it comes to the deployment. But for what it worth, let's jump straight to supply chain. So out of the box with Tab, we have 3 out of the box supply chains, right? So we have something called basic, which is what you see here. In the basic, there is no test or scanning capabilities. So just basic means that your code will go through the supply chain just to build an image, just to apply any convention. I'm gonna explain more what convention mean, and then just to run it as a Knative service on a Kubernetes cluster. This is a basic one. Next one is including everything in basic plus a test code. So we're having here a capability to test your code. This all gonna come out of the box. The way you test the code is that we have TestCon, and you will need to define a pipeline to be used for the source code testing. This is also out of the box. And this is the one we are using in the lab, which is including testing plus scanning. So this is gonna be the one that include all the steps that you have seen when Benoit run the workload for my Java app. Everything here, so includes test code for the source code, include a source scan using a tool called Gripe. It includes also image scan using the same tool, Gripe. There are some ways that you can swap this Gripe tool with another tool. So for instance, from VMware, we have a tool called Carbon Black for containers, like Carbon Black workloads for container, which can be swapped out with the Gripe if you would like to do so. But this is going to be the full supply chain that has all the stages for building, for testing, and for scanning. Let's check the CRD of supply chain. So while we are on the same menu here, same page on VS Code, let's just open supply chain. It's going to call cluster supply chain, so you have to go all the way up to the C letter, and you will see this is the one that we are using. I'm just going to here unfold annotation. I'm just going to care about what you see here, right? So again, what is a supply chain? A supply chain is a big template under which there are some other wrappers, template wrappers that are being called out to define the different stages of supply chain. So you will be able to see here some of these phases in the supply chain. For instance, source provider. What will be the source for my workload, for my source code? You will be able to see here another CRD being called out called cluster source template. This is all well explained in the lab, but for the sake of this session, we will not go through the details of every of these CRDs. But I'm just showing you how the big supply chain template have sub-templates inside of it, another sub-resources or custom resources being called out as part of the execution.
Yeah, and why we are showing that as well is to show you that if you want to change that, you can. It's just a YAML, a manifest. And if you want to add your own step as part of the supply chain, it's something that you can do.
Yeah. You will see here another stage called image provider. And you see here another thing called, I'm going to explain this in the UI, called lax scan policy. This is a scan policy that's going to be used for the scanning. You will see here that match labels. This is where we were defining in the workload. So we have either web, server, or worker. So if you're going to have, for instance, set to web, you're going to go to, you're going to use a template called config template here. If you're going to use server, you're going to use something called server template here. If you're going to use worker, it's going to be worker template. So all of these are going to be called out during the execution, and just using the basic labeled expression that you set in any Kubernetes manifest. I'm just going to skip using this for now. I'm just going to switch over to the UI. So let's go to tab UI and check how everything looks like from the UI here. So here's my workload. I'm gonna pick this one that Benoit has built with you, and you can see that all the stages are looking like they are healthy and everything is fine. So the first one is source provider. So what is source provider? Source provider is where you are having your source, right? This is your source code of the application. The way that this works is that you will see that as part of the build, everything you have in the source provider is going to be converted to a container image and being pushed to a Harbor registry. So the source provider, which is exactly the same directories you have in your source code of your application, will be pushed as a container image to Harbor, and this is going to be the link. So it's going to be an image URL. This is going to be your image. What is the version of this? What is the namespace being added to this?
So just to be more specific, it's not an image container, it's going to be a tarball containing all the source file. The image is being built a bit later in the process. But we use the registry as the source of truth. So we are sure that when we use all the source code, it's coming from a trusted source, and we can check that the checksum is the same, and we could even sign that if you want to.
Yeah, and the output of this will be a URL and revision. So the URL will contain everything we have about the tarball or the source code of my application, and the revision based on which version we submitted this. So if you're gonna commit perhaps a new change or commit a new change in the source code, another tarball will be created, pushed to registry, and there will be a different revision for this. So for any commit you're doing, any build, there will be one URL and one revision digest being added. The other one is source tester. Source tester, this is gonna be defined as part of the pipeline you're gonna have. So here we are using the runnable, which is gonna be the component that is used to manage everything when it comes to the testing the source. In our case here, we are using a Maven application. So this is gonna be basic Maven commands that will be used. You can see from here the logs of this source tester. So you can see all information. Just for us, we can see here test run 1, error 0, skipped 0, so means everything is healthy. Again, this is a very basic application with not so many dependencies, but you will be able to see that this is, once you have the tar file and you just gonna go through the tar file, this is gonna be all the files you have inside of your source code, and you're gonna go the scans through this using Maven, which is a basic testing for any Maven-based Java app. And then here we're gonna have the image provider. So the image provider is where we are now building the container image. So think of it as a stage is that we have first the source code. After source code, we have done the testing, and now we're gonna build it. So the way to build this is using, like I mentioned, TBS, or what we are calling Tanzu build service. This is gonna be based on a concept called cloud native buildbacks. You will be able to see some information here. For instance, what is the build tool? The build tool is called Cluster Builder Default. With out of the box in tab, we have different builders. The default one is called default, so this is the default builder, but you have different builders if you want to work around this. If you, maybe this is gonna be something to read more about it, go to Tanzu build service, read more about what Tanzu buildbacks is all about, how we can help developers to streamline these kind of building of container images. So in our case here, we are using the Java Tanzu buildback, but if you are using a different language, you will also have a different buildback used for this. Once this step is done, you will see that we're able to push an image to a registry. So you can see here, there's an image tag. So this image tag is gonna be the image tag that is gonna be pushed to the registry, and you can copy this as part of maybe configuration if you want to pull it for testing or something outside of the tab. But inside the tab, this is going to be fed into the next step, which is going to be the image scanner. So the image scanner is once you have your image pushed to registry, let's scan the image. Let's see what vulnerabilities are included in this image. So for this scanning, we are using something called a tool called Gripe. So you see in Gripe configuration, we have configured the Gripe connect to the image registry to make sure this is the image being passed on from the image provider, and it will scan the image and provide you the results here. So you will see the results, maybe it has a CVE, IDE, whatever, the criticality is high, critical, whatsoever, this is all gonna be part of the CVEs identified in this image. The good thing about Tab is that we are allowing you to configure your own policies when it comes to the scanning and the testing. So for instance, here you will see that as part of the policy that I configured called lax scan policy, like you can here add some not allowed severity. Not allowed severities means that maybe if your scan or image scan results in some CVEs with critical or high severities, maybe you will just say here not allowed equal critical and high. So that means that they will not be deployed to your environment. The supply chain will stop at this stage. There's also another way that maybe some customer would say, okay, this CVE could be a false alarm and we can accept it in the organization even though it's critical. So in that case, we will just go to ignore CVEs and we will say CVE number XYZ will be allowed to run in this environment. But this is all flexible to be configured. You can define your own scan policies the way you want and apply this to the supply chain. So we have complete flexibility in doing this. The next step is conventions. So it's called config provider. So convention is where you're going to add some extra configurations to your application. So let's say that you have a pod, you have a deployment. This is going to be all the Kubernetes, resources being deployed for your application. If you want to add any kind of convention service on top of that, convention service here mean extra labels, maybe extra configuration related to CPU, related to memory, any kind of you want to have a specific running for this workload. This is where it's going to be kicked in by the convention provider. In most of the cases, you will not do that, but if your application mandate to have some extra configuration, then this is something that you can configure as part of your config provider. The next step is app config, and app config is where everything we discussed in the previous status will have a config map for your application. So your workload is going to be more of configuration-based config map generated and applied to your Kubernetes cluster. Contains all the information we've discussed for your application, like what is the Java version used, what is the build version, what is the URL for the image registry. All these configuration are going to be stored as a config map in your cluster, and it will be used for the next stages. So the next stage will be the service binding. Service binding here is like Benoit discussed when he talked about the service toolkit. This is where you're going to connect maybe your workload to some external database, message queuing cluster. So if you have these kind of requirement in your application, this is where service binding is going to be used. We have partnered with a tool called Crossplane from a company called Uphound, just to allow you to have these kind of automatic provisioning and claiming of resources when it comes to database or RabbitMQ. This is not going to be something that we discuss in this module, but there is module 5 that we have created based on the integration with Crossplane, that you can take it at self-base here, HOL, or maybe after the event, you can take it at your own base. Another stage here is the API descriptor, and this is when you want to allow to expose some APIs from your application. So if we're gonna go here to, let me also show you this. So if we're gonna go here, for instance, to, from the tab GUI, we're gonna go to this API section. We're gonna see the application here. We're gonna go to the definition, and you will be able to see some APIs are being exposed that you can just deal with them using REST APIs or any kind of postman, maybe kind of call, get, put, batch, whatsoever. This is all going to be also done as part of the GUI. And the good thing is this is also embedded into the UI of Tab. So within the Tanzu developer portal, you will be able to deal with this APIs. Let's go back to our supply chain. So we were at the API descriptor, and now we are in the config writer. So config writer is adding on top of what we have in the app config. Config writer is going to be generating the workload that will be used to, or the configuration that will be used to deploy the application or the Knative service on the cluster itself. So this is going to be more of everything. We're calling it as the kind is going to be runnable. This is a CRD we are using. Runnable is going to be used to apply or run this on the cluster. So once we have this, we're just going to go to pull all the configuration. So pull the image. So we have the configuration of the workload, and we're going to just pull the image. And the next stage is just going to be delivery or running this image on your, as a Knative service on your cluster. And it's going to give you more information about the Knative service that you can check also from the CLI. But the outcome is this is going to be the URL that will be used to access your application. So this can be getting from either Tanzu apps workload list at the end, or Tanzu apps workload, name of the workload. It will give you all information about the Knative service, including the URL that you can use to access. You can also go to some CRD for Knative if you want to have the virtual service, if you want to have the host rules and everything as part of the configuration of the Knative. You will be also able to see that from the CLI. So this is more of the supply chain kind of concept that we walked you through it. And in the lab, you will be able to see that we are going deep a bit into the definitions of CRDs, like how to check this from, for instance here, how to just check the cluster source template. What is the cluster source template? How you can see it from the VS Code, or how to see the definition of the CRD itself. But I would say just because of now, we're going to be lost on all of these YAML manifests that we have to go through. So I prefer to go it in the easy way from the UI, and maybe later on at your own base, you can go through this and discover more about this concept of CRDs within the supply chain. I'm sorry. Any questions so far?
Okay, so I think if there is no question, I think we can wrap up. So if there is more question, you can stick around as well. We can discuss after the call. We also have few guests from the Tanzu product team. So if you want to talk to them directly, they are around here. So to wrap up about Tanzu application platform, as you might have seen, it's very, very close to Kubernetes. So you need to have a good understanding of Kubernetes and all its concepts with custom resource, selectors, labels, and so on. So that's very important to be able to operate properly the platform, is to know all about that. Then what we wanted to show you with, give you a bit of a deep dive into the supply chain is that everything is very transparent. Everything is inside the Kubernetes cluster. It's a custom resource at some point. So if you want to understand how it works, if you want to debug it, everything is there. It's just a matter of reading the YAML file and understanding the YAML file, and then you can understand why your supply chain is behaving a certain way. It's also easier to change the behavior of the supply chain because everything is there. There is nothing like hidden in a black box. At the beginning, I will agree it looks like a black box because you need to learn about all these YAML files. So there is definitely a ramp-up phase where you will have to learn about all of that. But when you are comfortable with all of that, it will make your life very easy as an operator, and it will help you interact with your developer also well, because you'll be able to decide with the developer what kind of policy to apply at which step of the supply chain, and implement that in the Tanzu application platform. The GUI, or the Tanzu Developer Portal, is the space where these two worlds, ops and developer, are meeting, because you can see all the workload that are being deployed. You can see the application deployed and look at the logs and see if they are performing well. And for the developer, they can also use that to look at the API of the other components, documentation, and a few other things. So we try to bring the two worlds inside a single UI. Everything you see also is accessible through CLI API, so it's very easy to integrate with your own tool chain. And finally, most of the components you've seen today are swappable, so you can use your own CI/CD pipeline. If it's Jenkins, it's fine. We have documentation telling you how to integrate with Jenkins and other tools as well. So I hope that it was not too much of YAML and Kubernetes, but I hope you enjoy it. And if you want to learn more about it, don't hesitate to take this lab again and look at the other module, or talk to us after the session.
Yeah, so we're also trying to make the experience like very easy when it comes to the deployment of tabs. So if you hear the announcement now with Tanzu Mission Control, you're able to install the complete tab profile in one of your clusters. So the installation itself is going to be very streamlined from Tanzu Mission Control. This is also going to be a super cool to have. And adding to what Benoit mentioned about, these kind of CRDs and everything, if you're going to talk to any developer you have in your organization today, they are doing this in a way or another. So they have their own tooling and everything. What we are doing with Tab, I think, is that we are trying to bring everything to be pure Kubernetes manifest. You don't need to rely on any RBM maybe installed on a Linux box or failure on Linux machine whatsoever. Everything is going to be Kubernetes, pure Kubernetes CRDs running, or custom resources running, and be able to integrate together. So the engineering behind this is what VMware is helping you to have. But from you, the UI experience for you as a developer or an operator, it's going to be all through the Tanzu Developer Portal, or even some basic Kubernetes commands that you can run to interact with your workloads. So I would say start using it now, start to read more about it. And we are more than happy to support you. If you want to get back to us and check anything, give us feedback on the lab, we will be more than happy to go through it with you. Appreciate your time, and thank you for joining.
Thank you.